Hello Year 8 and welcome to a day of water-based practicals. Now I'm going to show you some things that we can do to prove the properties that water has. So for each of these experiments, as I'm demonstrating them, I'm going to explain a little bit about the science. But what I'd like you to do is have a go at home and then research the property that I'm talking about for each one. So I've got a load of different things here. We'll start with they're all very exciting. The least exciting, I think, but it's really cool still, is you need a shiny surface. So I've just gone for a plastic wallet, anything like this, anything that would normally repel water. And your challenge, so normally I would do this with a little dropping pipette, but I don't have any of those at home, is to try and get just one droplet of water. And I think you can do that just by dabbing with your finger onto the surface of a laminated sheet. Now, I'm not sure how well you can see this. Can you even see that at all? Sort of, okay. But what you will be able to see is that the water makes a dome. And that dome happens because water has a property called adhesion, where it sticks to the other objects that are there. It also has cohesion, which means that it sticks to itself. So it stays in this ball shape with the cohesion that's there, but it also adheres to the surface. And what you can do is you could, if you have like a pencil or a matchstick or something, you can actually drag the water, you can move the drops together and they form a bigger drop. They stick to each other. The water molecules, the H2O molecules, actually stick to each other. The reason for that is because they're partially charged and one side is slightly positive and one side is slightly negative. So because of that, it sticks to itself. That's why we form this ball shape, and it's also going to stick on the surface like that. So what you can then do with this is if you just get a camera and you take a really close-up picture, if you've got a better quality camera than mine, you can get a really nice picture. If you can get down at the same level, you can actually really carefully see that dome shape, and you could look at what it looks like on different surfaces. So different surfaces allow the water to stick by different amounts. Something that is like a self-cleaning window hardly lets the water stick to it at all. So it will be more upright, that dome, that ball. Okay, so on to our next practical, which is looking at the same property, the cohesion of water, but when it creates something called surface tension. So there's two investigations that I'm going to do to show you. What you need is a bowl of water. Now, as you can imagine, this is going to be quite tricky for me to show you, so I'm just going to demonstrate what I'm doing, and then I'm going to lift it up. So I'll just move those out of the way. So what you need, and you can do this without a piece of tissue, it's just a little bit more fiddly. Please, can I have my paperclip back? Where's it gone? Okay, I found it. What you need is a paperclip and a piece of tissue. And what you're going to do is you're going to place the tissue on the water and put the paperclip on top. And then, if you use a matchstick or you could just use a pen, you're going to carefully push the tissue down. You really don't need that much tissue, actually. The less you use, the better. And you actually just want to get the paperclip, yay, to float on the water. Ugh. So let me lift my screen up so you can see. I've now got a floating paperclip. Now, the reason this happens is because of surface tension. So you might have seen pond skaters, those insects that sort of seem to be able to walk on water. They work by surface tension as well. If you look really closely at the paperclip, you will see it sort of bulges slightly in the middle. The water is cohesive to itself. Those molecules are sticking together and it's holding them tight. If you try and balance a paperclip, and do this before you try it with a paper, If you just try and put it on there, it just falls through. It doesn't have that tension. So that's that one. And as soon as you break the surface tension by sticking your finger in it or getting very close to it, then it just falls down. Now, you might have seen this one also looking at surface tension. It was sort of going around on the news quite a lot about germs. And what you need to do is you need to get something, it doesn't matter what it is, any kind of herb, anything that will float basically that you can see. Pepper. Willow, I need that one, please. Sorry about that. My children have stolen the next item that I need. So you need something that you can sprinkle on top of the water. And just sort of create an even covering. And you'll see there that it's evenly spread out. And the reason that it's doing that is because of surface tension again. The water molecules are cohesive to each other and they create sort of like a membrane, like the outside of a balloon. Now, as soon as you put your finger in, nothing happens because it just continues with that layer but goes around your finger. If you put something in that can actually separate those molecules, like washing up liquid, what washing up liquid does is it gets between the bonds and it forces that the molecules apart. So if I then put my finger in with washing up liquid on, it separates them out, it breaks that cohesion in that area there. So nothing would now stick to it. And if I was to try and put them on again, they wouldn't stick in that same place. They'd all go around the outside. So the parsley has been separated. The cohesion has been broken. Okay. So that's my surface tension paperclip and the herbs. Next one, we're going to need a flame. You're also going to need 2 balloons. I only had long balloons, that was all I could find. So you are going to have a look at a property called, sorry, can't talk whilst concentrating, it would seem. There we go. You're going to have a look at the fact that water doesn't change temperature very easily. It's got a very high specific heat capacity, which means that it takes a long time for it to change temperature. Now, this is why fish and everything else that lives in the sea can survive the changes of the seasons, and they can live at the very bottom whilst the top's frozen. They don't get affected because the change in temperature is so small. Now, I'm going to show you that if you hold a balloon over a flame, it will pop. There you go. I hope that got my jump as well. What you now need to do is to blow up a balloon again and put in a little bit of water. Okay. So once you've done that, and the best way to do this is to use like a garden tap to put it over the end like you would if you're making a water balloon. Put in a tiny bit and then fill the rest with water, with air. Now, I'm not sure if this is going to work and it's my last balloon, so I hope it does. You see, I've got just a small amount of water there. Now, when I hold it over the flame with the water in, it shouldn't pop, because it takes such a lot of energy for the water to change temperature that it won't pop. This is showing that water maintains its temperature. It's very steady in maintaining its temperature. So I'm going to get covered in water if it does pop. Okay, so as you can see, I'm touching the flame now, and it's not popping, and that is because of the property that I just mentioned. It's got a very, very high specific heat capacity. It doesn't change temperature very easily. Amazing. So what I'd like you to do is have a go at doing those experiments and fill in the sheet on Firefly, the template, as you go. Take a picture of what you've done and write a little bit about them. It doesn't matter if you can't do any of these because you don't have any of the equipment. Just try and do what you can. Have fun!